Hello, Math 2 Honors. This video is for Unit 7, Lesson 2. I'm going to break this lesson into two videos, one on lines and one on absolute values. So this video will just cover the first part of the lesson on lines. You should be familiar with lines, so we're just going to run through just a couple reminders. We've talked about slope in the last lesson, but we always had a graph that was on a nice coordinate plane with a nice grid, and so we could count the slope. So I want to talk about how to get the slope of a line if you don't have a coordinate plane. So I want to start by thinking about it kind of on a graph, and then we'll do it without a graph at all. So this line that I have graphed here, it shows or contains the point -5, 1. So this is -5, 1 over here. Whoa, that's not a very good 5. And the other point that it contains that we know for sure is up here. That's the point 16, 10. So we don't have a nice grid, but we do have some points and we can see the shape of that line. So if we did have a grid or we were able to count off the slope, we would just need to think about how much the line went up and then how much the line went over. Well, when we're thinking about how much it went up, we're really focusing on, let's see, I'll color code this a little better. We're really focusing on those y values and how much did they change. So the y value of that first point is 1 and it goes up to a y value of 10. Well, if I go from a 1 to a 10, I went 9 units up. And then we want to think about how far over it went. So when we think about how far over something goes, we think about the x value. So it started at an x value of -5 and it ended up at 16. And so we have to sort of add the 5. Where you can think of it as subtracting a negative, but we need to add the distance 5 to the distance 16. So it went over 21. I do not know what is up with my handwriting today. So if we're talking about the slope is a fraction, and it's how much you went up divided by how much you went over. So this is the slope of our line, 9 over 21. Now that fraction can be reduced to 3/7, so we would say our slope is 3/7. So what we've done really is we've used the slope formula sort of informally, but here it is formally. The slope of a line is the y2 minus y1 over x2 minus x1. We're going to use that to do some calculations now. So our first example, we want to find the rate of change of the line through the point 1, 2, and 13, 8. When you're calculating slope, it doesn't matter which one you call y1, y2, or you can do either way as long as you're consistent. So I'm just going to call this one x1 and y1, and we'll call this x2 and y2. So then the slope would be, I start with y2 minus y1, and I divide it by x2 minus x1. So that's 6 over 12, which is a slope of 1/2. If you had chosen differently, it would be fine. You could have chosen to do 2 minus 8 over 1 minus 13. That also simplifies to be -1/2. Just make sure that you're consistent. So if you choose to start with 8 and subtract 2, then you have to, on the denominator, start with 13 and subtract 1. So just be consistent. All right, so our next example says a line runs through the points -317 and 2, -13. What is the slope of the line? So we're going to do, let's see, I'm going to start with the 17. 17 minus -13. And since I started with the 17, I have to, on the denominator, start with the -3. So -3 minus 2. So our numerator ends up being 30, and our denominator is -5. So this line has a slope of -6. And we do usually use the letter m for slope. Okay, want to review just a couple graphs in slope-intercept form, and then our focus is going to be more on point-slope form in a minute. So if you are graphing a line and you have the equation in slope-intercept form, that means you have a number times x plus or minus a number. The constant is the y-intercept. So this function has a y-intercept of -4, and then we can count the slope from that y-intercept up 2 over 5, up 2 over 5. So we've got this line down here. That's an increasing line. And so then this next line has a y-intercept of 8, so we would mark this. And then from there, we will count that slope of -3. Now, if your slope isn't a fraction, it's just over 1. So this is down 3 over 1, down 3 over 1, down 3 over 1. And you just count it out and draw your line. For this one, I have given you the graph of the line, and we want to write the equation. So we need to know the y-intercept, which is 2, and we need to know the slope. So we have to look for another nice point that it goes through. I think it's right here. So our line is going down 1, 2, 3, 4, 5 over 3. So our slope is -5/3. So the equation of this line would be -5/3 x plus 2. Okay, well, what about this line? If we wanted to write its equation and we go to look at the y-intercept, you can see that the y-intercept is not an integer. It's somewhere between 2 and 3. So we don't want to make assumptions about what its exact value is. Instead, we want to use a different version of a line equation, which is called point-slope form. For point-slope form, we don't look for the y-intercept. We just look for another nice or a different nice point on the graph. So there's a couple that we could use. We could use this one right here, or we could use this one up here. Either of those would be okay. I'm going to use this one down here. So the point that I've selected to use on that line is the point -2, -1. So we just look for a nice integer value point that we can see on that line. And then from there, we want to count off the slope. So we have to find another nice point, and I think it's this one right here. So up 1, 2, 3, 4, 5, 6, 7 over 4. So the slope is 7/4. So then if we want to write the equation, we'll use this point hk, but the x value is going to go with the x and the y value is going to go with the y. So, and we have subtraction happening here. So I'm going to write it out twice with the subtraction. So it's y minus the k value is equal to 7/4 slope multiplied by x minus the h value. But we usually don't like to have these subtracting negatives in our equation, so we end up changing that to adding, because subtracting a negative is the same as adding. So this is what our equation would look like. So a lot of times people will just sort of like know in their head, okay, I'm putting a -2 in, I'm putting a -2 in over here for h, so that's going to be x plus 2. And you, instead of writing this step formally, you'll just go straight to the second equation. Okay, point-slope form just comes directly from the slope formula, so I want to show you that. Here's our slope formula. It's hanging on the wall in my classroom, or it's in your notes, and we're going to use these 2 points. We're going to use a point hk and a point xy. So what we're saying is we've got this line, this generic line. It goes through this point hk. We're not using numbers, but we know it goes through the point hk, whatever hk is, and we know it also goes through this point xy. Okay, so then if we put those 2 points into our slope formula, we end up with m is equal to, and I'm going to call this one up here my x2, y2, so it's going to be y minus k. So I did this y value, subtract this y value, and now in the denominator, I'm going to do the x's. So I'm going to do this x minus this x. So it's x minus h. So this is our slope formula. Well, I can turn this into the point slope form of a line by simply multiplying both sides of the equation by x minus h and cleaning it up a little bit. So on this side, I have an m and an x minus h. On the other side, the x minus h cancels out, and I have y minus k. So then it's really the same as our point slope form. We've got opposite sides of the equation, but it's the same. So really the point slope form is just a direct consequence of the slope formula. Okay, so here we're going to graph the line. All right, so we need to identify our point. The point that we're going to use, so you have to look at your x value first. This is x minus 5, so our point is going to be an x coordinate of positive 5. And then our y over here, we've got y minus 4, so our y value is 4. So our point that we're going to start with is 5, 4. And from there, we will count off our slope. Here's our slope. Our slope is 1/3, so we need to go up 1/3. It's kind of going off the coordinate plane there, so we need to go back 1/3 to get the rest of that line. Whoa, not the best line I've ever drawn. All right, there we go. So remember when you're looking at point slope form has negatives, y minus, x minus. So when you see a y minus 4, the y value is 4. When you see an x minus 5, the x value is 5. Okay, we want to write an equation for a line that goes through the point 3, -2 and is parallel to the line 3x plus 5. Now, I don't want to do a formal graph here because I want you to think about it, but a sketch can sometimes just help us think through it. So the line 3x plus 5 has a y-intercept of 5 and a slope of 3, so it's somewhat steep like this. So this is y equals 3x plus 5. We want a parallel line that goes through the point 3, -2, so somewhere like here. So the line we're looking for is a line that looks like this. Well, parallel means same slope. So if this blue line has a slope of 3, that means our line has a slope of 3 as well. So we're going to write the equation of our line in point slope form using this nice point and this slope. And we don't need to worry about finding the y-intercept or anything. So it's going to be y, it's minus -2, so that's going to be y plus 2 equals 3. Our slope, and then we want to have x minus our x coordinate of our point is 3. So this would be the equation of the green line. It's parallel to 3x plus 5, and it goes through the point 3, -2. So perpendicular, this one we want to write a perpendicular line. A perpendicular line is a line that is 90 degrees from the original line. So they meet at a 90-degree angle. So let's do a really rough sketch of this line, -2x plus 7. It's got a y-intercept of 7 and a slope of -2. So this is our line, y equals -2x plus 7. We want a perpendicular line that goes through the point -8, 1. So somewhere over here. So we want this line to meet, these two lines to meet at a 90-degree angle. So when two lines are perpendicular, their slopes are opposite reciprocals. So So you not only change the sign of the slope, but you also reciprocate it. So if this original line has a slope of -2, our slope of our line is going to be positive. And if I think of that 2 as a 2 over 1, the reciprocal of that would be 1/2. So our slope of the line that we're trying to write is going to be a slope of positive 1/2, the opposite sign and the reciprocal. So our line is going to be y minus 1. So I've got to use the point that I'm going through and the slope. So y minus 1 is equal to 1/2 multiplied by x plus 8. And this is the line or the equation of that green line. Okay, that's it for the line portion of this lesson. So on the assignment, it's the front half of that orange assignment in your notes. So let me know if you have any questions. And there is a second video for the absolute value part. Thank you.